If you are a product designer today, you probably don't want to use 3D printing for a functional version of your design because you're not sure that the properties will be good enough. 3D Matter is going to change that. We model and forecast 3D printed objects' behavior so that you can know in advance if the properties are sufficient and even optimize the outcome. We integrate material science into product design. 3D printing is amazing because it brings this brand new freedom of design to the user. But this freedom is also a curse. If you look at the X-ray of a printed part, it is actually a complex structure inside, not a homogeneous material like in traditional manufacturing. This is why 3D printed parts properties are so hard to forecast. Traditional testing methods are not good enough for this new complexity. So currently, parts properties are not predictable, not reliable, and not replicable. The current approach to 3D printing is trial and error, and it is often limited to prototyping applications or niche applications where a lot of industry-specific research has been conducted, like dental applications, for example. So to unlock 3D printing to a much wider range of functional applications, 3D Matter has designed a very thorough procedure that can be applied to any 3D printed materials. The research tests three criteria: mechanical performance, visual quality, and processability. And with the extensive data that we're collecting, we are building Optimatter, a forecasting model that helps users choose the right material and the right parameters for their application. Our first commercial version, already available, is an online software that compares and optimizes printing configurations. For example, you want to print a hairbrush. Well, you input your requirements in our software and it will suggest the following materials and settings. For the handle, Ninja Flex at 30% infill and 0.25 millimeters layer height. For the main body, ABS at 40% infill, etc., etc. You will have a guaranteed functional part and you will have saved half the cost and 70% of the printing time compared to standard parameters. In the long run, you will even be able to modify your object shape based on the material properties. We've identified product designers, printing service companies, and universities as our target customer segments. They're the segments that need good data for their applications, but don't have the resources of large industrials to invest in their own research. In addition to the unique testing procedure that we showed, we have two key competitive advantages. The first one is that we provide unbiased, independent data. Unlike material suppliers, who usually use very flattering testing procedures for their product. Second, we develop a lot of data at a low cost. The graph on the right shows our cost structure versus third-party testing, and you can see that we're about 5 times cheaper. To get our product to market, we will rely on two main channels. Our website, which is very popular, with about 4,000 sessions a month, and partnerships, in particular integrating our tool into slicers and printers software. If you don't have Optimatter in your software, then you're lagging competition. To expand our database to all the materials and all the parameters needed to fully forecast 3D printing, we need to raise about $500,000 by the end of this year to buy equipment and to hire talent. To meet this plan, we have a team of engineers that combine an in-depth understanding of materials and a math background to build a model. 3D Matter will bring 3D printing to the next step, functional parts. Thank you for your attention.